think I've had enough. I might get a little drunk. I say what's on my mind. I might do a little time, 'cause all of my kindness is taken for weakness.
This goal, in a nutshell, is what chemistry is. From Gen Chem to P-Chem, thinking critically is the only way to survive. Analytical thinking? Come on. It's called analytical chemistry for a reason. Integrative thinking? How to use science. Without integrating and building upon other people's work and ideas, there's no way to further understanding of how our universe works. To fucking duh. The definition of integrative thinking. Maybe others have issues with this, but not us. Every class, every lab demands critical, analytical, and integrative thinking. Chemistry majors eat, sleep, and breathe this way of thinking. No reflection needed. This is how we live, how we think, who we are.
As a young boy, I often dreamed of possessing uncanny creative and reflective capacities, such as leaving a crowd standing in awe as I walked off stage, away from a flaming podium. Unfortunately, these dreams never came to fruition. Rather, I followed my heart and became a chemistry major. Contrary to my naive assumptions, I eventually realized that chemistry would demand the entirety of my creative and reflective capacities. Needless to say, encounters with creativity in relation to chemistry are continuously daunting. My palms were clammy as the words, "propose a model distinguishing the crosstalk between the Wnt and Hippo signaling pathways," spew from my professor's mouth. I realized that I must reflect on the entirety of my knowledge, even after I've regurgitated everything I learned in class, as well as the main concepts from primary literature, such as azoline et al., YAP and TAS incorporation, the beta-catenin deconstruction complex, orchestrate the Wnt response. The answer still doesn't present itself. I need to be creative. How can these concepts come together? What principles should I highlight to justify my model? I panic. Before I melt down, I realize more words are disgorging from my professor's mouth. He adds, "Be sure to include an experiment to sufficiently test your model." At this point, I'm in a flashback. My childhood dreams begin to play over my head as I dislodge from reality. As I awaken, a thought lingers in my mind. This is my chance. I haven't abandoned my dreams. I realized that I had been building my creative and reflective abilities throughout my entire chemistry experience. During my laboratory exercises, I have worked around mistakes, experimental design and error, data interpretation, and data representation. During class, I have worked through open-ended questions and displayed complex problem solving. All of these things require intense reflection of the concepts at play and specific goals pertaining to the issue at hand. Creativity comes in through the synthesis and implementation of ideas. Suddenly, I realized that I had been preparing for this moment my entire life. I reflect on all of my knowledge and past experience and creatively synthesize my ideas into a concise and coherent presentation, effectively meeting the demands of my professor. With my uncanny creative and reflective abilities, I gave my presentation to the class, leaving an awkward silence as I took a seat.
Leadership. During my college career, we were assigned myriad times to lead a class by presenting a scientific topic. The scientific topics range from organic to inorganic chemistry. I would talk about the topic and then answer questions from inept classmates about my topic. The topic that was most often spoken of related to the topic of Frank's research, i.e. spiders and other scary things, e.g. Frank's dry humor. In terms of personal leadership examples, I was vice president of the Hillel because I'm Jewish. But it sounded like a lot of work, so I endeavored to pursue other avenues in leadership. Collaboration. Throughout my college career, collaboration was essential to both my learning and the growth as a student and member of the college community. I remember one time when I was a 22-year-old boy, when I was asked by my chemistry professor to work with a fellow chemistry students and the outlier physics students on a computational-based laboratory that was focused on analyzing the thermodynamic properties of several refrigerant compounds such as sulfur dioxide through the use of computational methods like the Debye extrapolation for the determination of the constant pressure heat capacity. All of us students in the chemistry classroom banded together as one to pool our mental resources and complete the rigorous challenge presented by our teacher in the form of this assignment, at which point our teacher proudly stated, "It was a beautiful sight to see," in regard to our collaboration on the assignment. Teamwork. My college career, the whole time I was faced with the predicament of overcoming the obstacle of dealing with unfavorable laboratory partners. Thusly, we learn to creatively function within a team to address the overall needs of completing a project. In summary, throughout my college career as a chemistry major, I was able to meet the leadership, collaboration, and teamwork goals. Studying chemistry provided me with ample opportunity to learn and subsequently refine each of the techniques necessary to complete these goals. For example, in my senior level physical chemistry class, I led a class discussion at the end of the semester pertaining to a peer-reviewed journal article. In addition, I conducted a computational lab with a fellow physical chemistry student, and together we wrote the lab report. Lab reports written by two people are distinctive in that they combine two unique perspectives. One technique that I was able to refine throughout my entire career was collaborating with other lab members, then methods outlined by the professor did not produce the expected results. During these instances, I learned that collaboration with my fellow lab mates is invaluable to remedying the problem and determining the best course of action to complete the lab in a timely and appropriate manner. The teamwork, collaboration, and leadership skills I acquired as a student at Westminster College will invariably lead me to success outside the classroom and in the medical field where I am headed.
I have a single perfect example for this learning goal. The 40-page biochem lab report, Mary Mother of Fuck. I don't know whether everyone's lab report was as long as mine, but that semester-long project squeezed 40. Let me repeat, 40 fucking pages out of mine. But that semester-long project, remember how we all went into science because writing was like, not really our thing? Well, too fucking bad, because William Deutschmann is here to make sure that you can write beta-galactosidase for 40 fucking pages. But really, at the beginning of biochemistry, none of us had any idea what we were doing. We had written lab reports for Gen Chem. By lab reports, I mean maybe one actual lab report, one time, and if only you were in Will's class to begin with. And Will's requirements were, in a phrase, hella specific. Just as the requirements for publication vary among journals, the attributes that constitute an acceptable lab report vary widely among professors. Will requires a succinct yet detailed description of everything, which makes faking your way through a writing assignment entirely impossible. You better know exactly what you did in lab, and exactly why you did it, and exactly what those results mean, and exactly what the fuck that Lineweaver-Burke plot is supposed to represent. And, by the way, those Lineweaver-Burke plots, they show the inverse of the concentration of substrate versus the inverse of the initial reaction velocity in terms of disappearance of substrate. Making those measurements is complicated. Making those plots is complicated. The results you take from those plots is only good if your data is flawless. And you had to be able to communicate exactly why, if your data and plot were not flawless, why they were not flawless. Will also absolutely no tolerance for wandering sentences of fluff. Apparently, in the year before mine, he had actually commented on a student's paper. Honestly, I stopped reading this. It's too long. To write an effective biochemistry lab report, you had to know your audience, i.e. Will Deutschmann, and your material, i.e. oh my god, all the millions of experiments we did. Essentially, this lab report and all other lab reports we composed forced us to demonstrate a sophisticated awareness of the context, purpose, and audience and objectives of our project. We also had to provide substantial evidence for all of our claims, including extensive references, and show detailed and broad awareness of the conventions and acceptable types of writing for scientific reports. All of these contributed to our understanding of the learning goal of writing and other communication.
It is important to use green solvents to reduce harm
that non-green chemicals can create. Iron oxide core shell nanoparticles are a green chemical
used to replace palladium. They are used as a catalyst for hydrogenation of olefins. Palladium is extremely
detrimental to the environment. Carpooling is a great way to save the environment. We have learned that it is
important to be ethical in our science. It is wrong to spread
false data. There must be evidence to substantiate each claim. It is unethical
to falsify lab data or to clone other humans. It is important that all lab procedures be reproducible.
We have a responsibility as scientists to present all data, evidence, and conclusions in accurate detail.
Do it.
Whoa.
Beta galactosidase. Corey, say it.
It is important. Beta galactosidase. False data.
Beta galactosidase.
Beta galactosidase.
Beta galactosidase.
Because I'm
Nate. Beta galactosidase.
okay. Hey Carissa, I just get really grumpy after 9 p.m.
Experiments is we had to do.
I don't want to give you too bitchy of an impression.
I will bleep that out in the edited portion.
My mother could see this.